Alright, so this is 19. Synthesize 3-methyl 2-pentene from 2-chloro 3-methyl pentane. And they want us to choose the reagent, right? So here is the molecule 2-chloro 3-methyl pentane. We're going to produce 3-methyl 2-pentene. And what reagents are we going to use? So, right, elimination reaction is wanted with no SN1 or SN2 competition. So it's a second-degree substrate, right? So we know that if it's a second-degree substrate, a strong base, good nucleophile, and maybe a little bulky will help give us E2 over SN2. And we also know that heat will favor elimination over substitution. All right, so let's look at our answers. Sorry if the sound quality on this is strange. I'm getting reverberation on my microphone. So I have CH3, CH2O. It's ethoxide, sodium ethoxide in ethanol and heat, right? So this is, I have a good nucleophile, which is a strong base. So that's probably going to favor E2, right? Next, they give me hydrochloric acid plus heat. That's a strong acid, not a base, so that's not going to help me. Then they give me ammonia, aqueous ammonia. Oh, it's in water. So if it's in water, I guess it could become a base, because let's see, we have water is more, oh no, water is more acidic, but then I guess you could get OH molecules. That technically could become a strong base because it could turn into an NH2. It could turn into an amide molecule if it's in water. It's at 25 degrees Celsius. I guess it's more likely to stay a weak acid than to become a strong base. This could be, this actually could be an option, maybe. So then we have, we have sodium acetate in acetic acid and heat. So we have a good nucleophile and a weak base. So that's going to favor SN1. So let's say, since it's going to favor SN1, we're going to say like no to this. We said no to this. Then our fifth option is ethanol and heat. That's a weak nucleophile and a weak base. So that's going to be SN1 or E2, E1. And the heat will make it maybe a little bit more E1. So with the exception of this, I think this could be an answer if it's aqueous ammonia. Maybe it could lose its electron to hydroxide anions that are produced in the water, but I guess there's just not a lot of that going on. So that's why it's not the answer. This is the answer because the heat and the fact that it's a good nucleophile and strong acid is more likely to pluck off the hydrogen that's right here and create a double bond. I guess let's just do that mechanism real quick. Right, the mechanism. So we would have there's a hydrogen right here, and we have the ethoxide, the sodium ethoxide, and it's in ethanol. So it's more likely to pluck off the hydrogen, the hydrogen that's connected to a third-degree carbon, than it is to pluck off what's it called, a terminal hydrogen, because this hydrogen is less strongly held to the carbon. So it's very likely to come here. It's a strong acid. So it's likely to pluck off the hydrogen, which will give it double bond here, and the Cl will leave. I guess this is a second degree. Oh, you know what? This is a second degree carbon, but this methyl group right here, there's a methyl group here, a methyl group here. That makes a lot of crowding, and it might make it difficult for this sodium ethoxide strong base to come up in here and attack this nucleophilic center. This is the nucleophile, this is the electrophile. It would make it more difficult for this to come in here and attack this, causing an SN2 reaction. So this is the likely mechanism that would happen, giving us the product that we want.